In this video, we're going to talk about how to use the counting methods that we've discussed in order to compute probabilities. So this first example, find the probability of being dealt a royal flush in poker. So we're going to compute this the way we did our very first probabilities, but using counting methods. So I first want to think of this probability as taking the number of ways to get a royal flush and then dividing by the total number of possibilities when being dealt a hand. So this was a method of computing probability that we saw early on, but in this case it's somewhat difficult to figure out how many possibilities there are for each of these. So the number of ways to get a royal flush, if you're not that familiar with poker hands, that's not a big deal. This is just an example. But for a royal flush, you're getting all of the high cards of a particular suit altogether. So there's only one possible royal flush for each suit. So in our deck we have 4 different suits, which means there's 4 different royal flush hands. So the only way to get a royal flush is if you get one of those 4 particular hands. So we're looking at 4 possibilities out of the total number of possible hands. Here's where our counting methods come in. So the number of possible hands, we're taking this whole deck of cards and we're going to pick 5 of them for our hand. Now we mentioned this in the counting methods section. We're taking a total of 52 cards, we're selecting 5, and in this case, because the order of the cards doesn't make a difference, this is going to be a combination, or 52 choose 5. So we just take 4 out of that total. And again, you can compute this on the calculator. If you're not sure how to do that, go back and watch the counting methods video. And then we could compute a decimal for this if we wanted to. If you compute this on the calculator, you'll see an answer something like 1.539 and some more digits, and then that capital E -6. Remember, this is scientific notation, so this means times 10 to the -6 power. So we have to move our decimal place 6 places to the left, which means we're going to have 5 zeros and then our number. So this is a very small number. Even if we converted this to a percentage, this is 0.0001539%. It's extremely unlikely to get a royal flush. Another example, a little bit more related to statistics, imagine you're conducting a drug trial and you have 10 participants, half are men, half are women. So when you do a drug trial, of course, we have to take a treatment group and a placebo group. So if we selected 5 people at random to be in the treatment group and then the other 5 would be in the placebo group, what's the probability that the treatment group ends up as being all men or all women? So again, we want to do this same idea of saying, well, what's the number of ways that could happen out of the total number of possibilities? So in this case, the number of ways to get all one gender, well, you can either get all women or all men, and there's only one possibility for each of those. So there's 2 options of having all of one sex or one gender. And then we have to say, okay, well, how many different possibilities are there if we're selecting a group of 5 people from a total? So again, this is a counting methods question. We have to decide what method to use. Because we have a pool of people, 10 possible people, and we're picking a group of 5, I would expect this to be either a permutation or a combination. Then our question is, does order matter? Well, no, because the treatment group is just the treatment group. It doesn't matter who gets picked first, second, and third. So this would be a combination, 10 choose 5. We can compute this out. And this is saying that there are 2 ways where you could have all men or all women out of a total number of possible choices of 252, or this would be 1 out of 128. So if we can convert this to a percentage, this comes out to about 0.7% chance. So should we be concerned about this is really what we would be interested in here. we really wouldn't want the treatment group to be all men or all women, because we want to have a mix of sexes when we're talking about doing a drug trial in case gender becomes a factor. This is one reason that oftentimes when you do drug trials or something like that, your sample gets split into two pieces and you do the men and the women separately. But the probability of this happening is fairly low, so it's probably not something we would be too concerned about if we wanted to use this method. All right, one problem for you to try. This is about guessing credit card numbers. So just remember, you want to be thinking about the number of ways the event can happen out of the total number of possibilities. And other than that, just think about your counting methods and which one would be appropriate here. That's all for this video. See you next time.